Yeah, today we're going to take a little look at how OPC UA looks in CODESYS and what do you do with it. Thank you, Stefan, for explaining what OPC UA is in all detail. Now I don't have to do that. Maybe as a quick reminder, you might remember that OPC UA is two parts. One is like the infrastructure, the transport layer, but then there's a big part of the information models. And since the infrastructure, it's like talking about roads. It's not that interesting. I'll be talking about the information models up here and what you can do with CODESYS. Maybe about how it is right now and what CODESYS offers currently. CODESYS implements the PLC Open companion spec, which is one of the oldest companion specs. It was one of the very first after UA was created. And its goal is to expose 6.11.31 code into OPC UA. And as you can see from this information model, there's a type called block type, which is then a POU type, which then has inputs and outputs and in-outs and local variables and external variables, and it can contain other function blocks. If you then take a look at this example here, you can see that we have our CPU that's running a program, which is associated with a task, which then contains a function block called motor, which then has input and output variables. So it's very focused on the 6.11.31 code and giving a one-to-one representation of the code you wrote in an OPC UA information model. In practice, this currently means that if you have a device, let's say it's the Fryer 5 million, which is like an industrial fryer you would sell to a fast food company that has like a big kitchen with lots of devices that probably want to be integrated. Your kitchen is big. It has a SCADA. You might have seen them like when you get fast food, how they have the screens that show you like the status of your order, basically. Stuff like that needs data, and OPC UA is a great protocol to do that. You sold your UA Nerval fryer, and then there's this guy he's not really a system integrator because he's not really from automation engineering and what we would call a system integrator. He's more a kitchen integrator. He's focused on building a kitchen that makes cooking fast and efficient. He wants to set up the SCADA. He brings out his tools and he's like, hey, what kind of OPC UA device are you? And then the fryer answers, I'm a PLC because I implement the PLC Open companion spec. That's the current state. And then usually that would go that the kitchen integrator is, what the hell is a PLC? Because for us, it's obvious. We've built a PLC into this fryer to automate it. Makes great sense. What's there not to understand? But the kitchen guy, he's never seen a PLC. He doesn't even know what the acronym means. That's not great. But that's where the companion specs that Stefan mentioned come into play, where you turn the data into actually useful information. And like how Equinor uses UA to put context around their data, companion specs can do that too. Because there is a companion spec for commercial kitchen equipment. And if you implement that, then the answer, what kind of UA device are you? It's going to get a reply, I'm a fryer, which tells the kitchen integrator everything they need to know. They have the context to get the right variables very easily and quickly with no support calls to the Fryer 5 million company. In detail, the commercial kitchen companion spec defines, among others, this fryer device type, which is the UA object type for fryers. And you can see it has a bunch of variables. Is this fryer one that has an automatic lift that goes up and down? Like details on the energy source. And then some stuff about how many cups there are, because there might be more than one. All that stuff. And then for each cup, you get then very detailed information like what the temperature of the oil is, how long it's already been cooking, how much it still has left to go, whether the lift is up or down, lots of information. But you could probably very easily tell that just knowing you have a fryer and then seeing those variables, you could put context to it right now. And you probably don't know much about industrial fryers. That's the real beauty of the OPC UA companion specs, that you can make it easy to have context. That was the intro to my demo here. Now let's take a look how we could make our fryer show up as a fryer in OPC UA. At the very beginning, I would kind of like to start with the old example of how it used to be. And that uses an object in CODESYS called the symbol configuration. So I can add my object here and select the symbol configuration. Oh yeah, maybe first I should show you my application. My application here is a very simple program. It just calls one function block called the fryer. And if I go into that, I can see that it has a PID for the temperature, and then some latching for the up-down logic. And that's kind of not a very complicated application. And then I have a little visualization to see the state of the bucket at the temperatures and times. Let's add that symbol config to see what we got. I just add this object here, and then I can say OK. And then I need to rebuild. We have all the information about the variables that we have in the project. And once that build is done, I can then expand my code here, and I see that I have my PLC program, which then has that fryer function block. I could go into details, or I can just make my life simple and check the box to expose all of them. And now if I want, I could set the access rights to be either like read only, write only, or like none. In this case, I want it just to be read write, to be like quick and easy. Now I can take this application, I can download it to my controller, and then I can call up my UA client, which in this case, I'm just using UA Expert because it's a great tool for like engineering purposes. And then I can go into my tree. This bottom left corner here is where you view the data model of your UA server. And I'm already connected to the local one on my computer. So I can go into the device set. Then I see I have a CODESYS control win, the soft PLC on my laptop. In that I have my application. Then that application has a program, which is called PLC program, which then has the fryer. Good. And I see I have a lot of variables here. Since I wrote that code, I know that the current average temperature is how warm the oil is. And then maybe I want the start switch in here as well. And I see that it's 0 right now because I actually didn't start the application. Let's do that real quick. And now we can see that the values are coming alive. We can watch how miserably tuned my PID loop is because I'm really not good at that. But you know, it's a demo. Nobody gets burned. We can see how the value constantly updates, and that goes close to the 250 that I set. If I look at my visualization here, I can then, visualization. That's cool. Oh, I guess I have an error in that. I can also start it from OPC UA here because I made it read write. So I can start this here and send that, and I can see now that I've put the frozen fries in, the temperature like got out of whack again, and the PID is trying to tune it again. But that's a quick and simple way how I can get variables from a CODESYS application into OPC UA. It is quick, but it obviously has the downside that if somebody wants to integrate this fryer that has this PLC in it into their kitchen now, I will probably have to explain to them which variables are important, like which ones to look at, what each one does. It's a custom information model, and the structure isn't very nice for somebody that didn't write the application and really doesn't care about what the variable names are. Let's go to the future, or well, to the present more, and use an OPC UA companion spec, in this case, the commercial kitchen spec, to represent this. I can add another object to my CODESYS IDE here. And in this case, I want the communications manager. And then under the communications manager, add another object, which is the OPC UA information model. So I select that, and I can pick the commercial kitchen one, and I want to call it the commercial kitchen. I spell it right, yeah. So now I can add that, and I got my information model here. And if I click on this, I can now get a view of this. This left view now shows me all the object types that are defined in the specification. So you can see there's a coffee machine, there's a cooking kettle, there's a dishwasher, and there's the fryer. I want this fryer type. What I'm going to do is just drag this fryer over to this side, and then CODESYS will look at that type and find all dependent types and add them to my project. Now, if I look into the fryer device type, I can see all the detailed, all the OPC UA variables contained in that type. And I can see that there's this column called generate member. And it's basically the ones that are checked. I will create 61131 variables for that I can then fill with data. Anything I want that's optional and that should be present, I need to check here. For example, there was the device location name, which I think means where that device is located. I want that to be there. And then I have the fryer cups, that's the placeholder. And to fill that placeholder, I can take the fryer parameter type and I drag it on there. And then I will get an instance of the fryer cup. I can rename that to be fryer cup 1. And now I have a fryer that has 1 cup in it. And then I can go down to the fryer parameter type. And since my fryer will have a lift, I can have it show it is lift. Now I've got what I want in OPC UA. Once I'm done with that, I can hit this generate IEC declarations button. And when I do that, CODESYS will generate us a lot of function block and enum types that represent all these UA. We can see, for example, we have our fryer device type here, which then contains OPC UA variables for all the things like we can configure, and it contains our fryer cup 1. Since this is 61131 and what set the values, I need to modify this a little bit to make this var input. Otherwise, the 1131 compiler will complain that I'm writing to an internal variable. And on the fryer parameter type, I need to do the same. And that's already all the messing I'm going to do with those variables. We can see that inside our fryer parameter type, which is used for the cups, we also have this lift up variable that we selected. We have a current temperature. We have some time variables. That's all of it. Next up, we need to instantiate them. So what we could do is we have our CFC with our main application. Now we could add a box. We could say it's a fryer device type. Quick tip, if you hit Control and space, then autocomplete will run. And either make you suggestions, or if it's already unique, it will fill it up. We could declare that here, and then we could wire up all these pins with the right data from our fryer function block. But since this would be tedious, I went ahead and prepared that for you. You don't have to watch me draw lines for 5 minutes straight. I did that here. Take out my prepared one, rename it real quickly that the compiler doesn't notice. Don't want to refactor. And we can see I have my fryer device type here that I'm feeding all the information from my fryer cup into, and the fryer cup itself is also broken up into a lot of sub pins. And then in the declaration area, I also just set initial values for a lot of the pins that don't update. Yeah, but it's just instantiate, wire up, and that's all we got to do. So now we have an instance of this. We can go, instead of the information model, which is like concerned about types, we can click this like commercial kitchen level editor view here. And here we have a list of all the 1131 function blocks that like have mapped UA objects. So I can hit this search for map instances button, and we can see it found our Friar UA object that we declared on our CFC. It also found like an implicitly generated one, which we don't want. We're just going to delete that. Now that Friar UA object type is going to create a UA object in our device set node in the UA model. And we can also rename that. We can just make it Friar. Now, if we now log in again, then this model will be used instead of the previous one, actually in conjunction with the previous one. And our users should be able to see our Friar, which contains a PLC, as a Friar object in OPC UA, which will be very useful and make their life so much easier. And in connection to that, also our life easier, because we need to provide less support for it. I can go back to OPC UA here. If I re-expand our tree, we now see in our device set, we have this Friar. And we can see it has all the variables that we saw. And then we have our Friar cup, where we also have the actual temperature. We can drop that in here. We can see it has the same value as the internal variable we picked up earlier. And if we start our Friar again, then we can see it also changes. That's how quickly you can take your application and use an OPC UA companion spec to provide the information from within that application. It's really easy to, whatever industry you're serving, your PLC application can be made so it has the right UA information model for that industry. And the user within the industry will immediately know what to do when they look at it in OPC UA. That's the end of the part of the demo where I show you how to get data out of CODESYS applications. We saw two ways: the real quick and dirty way, which was just like adding a symbol configuration, checking a box, and it was available. And then the little more sophisticated and user-friendly, where we went through the effort and made the UA companion spec information model, even though it wasn't actually that complicated. Yeah. Next up, I'm going to show you how to get some data into an application through OPC UA, because it's nice to share with everybody, but maybe you want to read some values from like a compute logic or some other UA device. That's also very easy. We add another object to our application. This time it's called the data sources. So we need a data sources manager. And then inside the data sources manager, we need a data source. And here we can pick the OPC UA server, and we can rename it the UA client because we're reading from a UA server. We can hit add. And now this wizard is going to ask me about some information about the UA server I want to use as a data source. So I can either just use a noteset file I have installed in the IDE, or I can say online, and then I just enter the connection endpoint for the UA server I want to use. In this case, I'm just staying simple and using the local host, port 4840. And now what the IDE does is it has a built-in UA client that now browses the server and looks at all the nodes that are available in it and offers them for us to subscribe to. So we can see all the Friar variables here, and then the Friar cup. But we could get any of these variables into the application. But for my demos, I personally really like this current time variable in the server status, because it updates by itself every second. I like to use that one. I'm going to pick that. I'm going to hit finish. And now the data source was created. I got to check this update always box here. Otherwise, it would only update what I use in visualization. And I don't quite want that yet. I can go back to my CFC. I can take an input pin, and then I can say it was our UA client. And it has in server, and then server status, and then the current time. That's the variable we're subscribing to. And if I go online now, it's compiling all the code we added to the application for the data source. It'll take a little minute. Once it's done, we will see that this variable will be updated to the current time via OPC UA. We can run here. Now we see our UA client connected, and the time switched from its initial value, which was January 1st, 1970, and it's showing as the 4th of October in UTC. And that's all it takes to get information into the CODESYS application with a UA client. As you can see, it's not any harder than getting information out, which isn't hard either. And with that, I'm going to end my demo here. If I find the button, whatever. Oh no, I want to go back to slides. There we go. That's the button. Yeah. To sum it up, it just takes a few clicks to expose the really simple PLC Open UA model. If you want the full feature companion specs, it's a little more effort, but it gives you great structure. And whatever machine you're building and selling in OPC UA, it looks like the machine it is, and not like a PLC, which is a great benefit. And using the UA client to get UA data into an application is also really easy. Anybody could do it. Now, going back to the layer diagram, we just spent a lot of time talking about the UA information and application layer. For our demos, I also used the transport layer for UA client server. Then there's also this other transport layer called OPC UA pops up. And for that, CODESYS has a function block library. So you can just instantiate some function blocks to create OPC UA pops up subscription. And this is really great to talk to some pops up enabled field devices and things like that. Yeah. Now, everything I showed you in this demo is with our current released version. You could just download CODESYS from the store right after this, and you can try it yourself. But looking ahead into the future a little bit, where's CODESYS going with OPC UA? One thing we're working on is like a new GUI for the symbol configuration editor, because like with user rights, the current one is getting to implementation. We're working on a new and better one. That in a later version, we also will plan to include OPC UA pops up into this. Publishing variables via OPC UA pops up will also be just a few clicks with a mouse. And then you're doing it, which is really nice and easy. We're also working on alarms and condition support. So you can have like alarms and events go out over OPC UA to notify systems of changes instead of them just constantly polling something. And we're working on historical access, which is real cool because then you don't just get the current value of a variable. You can also look for previous values and get an idea of the tendency and the trend. And it's great for historians because they don't need to constantly sample. They can just collect the historical data every couple of minutes. Yeah, some of the benefits of OPC UA in CODESYS is the first one is that it's all built in. There's no converter box, no external software that you need, no extra tool to configure it. It's all integrated. Like the editing is in the CODESYS IDE, and the execution side is in the CODESYS runtime. Nothing else is needed. And it's better than a lot of other vendors that like to make money of selling you extra applications and extra boxes that you then need, and then they break, and then you buy new ones, and nothing of that is the case with CODESYS. It's also really easy with CODESYS. As you just saw, I showed you 3 different things in 10 minutes. That's the fastest way is like basically no effort. It's like checking 2 boxes and everything's available. Companion specs, a little more effort, but much better results. And then UA client, obviously also quite easy and intuitive to use. It's also that CODESYS sees OPC UA as a very important protocol going forward. And we're putting a lot of resources in it and adding new features to it on a constant basis. We'll be always excited for more there. Yeah, that's what CODESYS does in terms of OPC UA, but we do acknowledge that OPC UA doesn't solve every problem yet. FLC will expand its scope, but it's still not going to solve every problem. You still need some other protocols to talk to web services and certain applications. And we still have all our field bus stacks to talk to the existing field buses we have. But on the cloud side, I also like to point out that we have a big library of what we call the IIoT libraries package and the OPC UA PubSub library. And you can use those on any CODESYS controller. And with those function blocks, you can basically make any of your applications talk to a cloud, either via our Azure and AWS IoT connecting libraries. You just drop in a few function blocks and you can send data to the cloud. It's really nice and easy and great for cloud applications. And the best part, because it's function blocks, you can put those blocks in ladder, and then your ladder logic can go all the way to the cloud. And with that, I'm going to give it back to Chris.